The topic I want to talk to you today is called Automate Creation of CD Pipelines for Accelerated Application Delivery. So before we start talking through this, I'd like to get, it's going to sound a little silly, but I'd like to get the name of just like a zoo animal. Anybody?
Zebra.
Zebra.
Camel. A liger.
A liger, okay. So hang on, I'm getting used to a couple of these new Mac shortcuts. What I'm going to do is we're going to talk through automating setting these up. I'm going to set up a CD pipeline using Zebra in the DNS entry so you can kind of walk through the process with me. So we're building this thing that lets us automate the creation of them, and we're going to see a little bit under the hood as we work here, but I'm just going to run this command that's going to spin up this CD pipeline, a brand new CD pipeline from scratch, and that takes like 30 minutes, so we're going to spend the rest of the time while that's going doing other stuff. I'm just going to make sure that it kicks off okay. Yeah, that's good. Okay, so so when we say accelerated application delivery, what do we exactly mean by accelerate? You have an idea. Maybe that idea is something that's going to deliver business value. Maybe that's some data that you can get to figure out how to improve the software that you're building. But then after you have that idea, some time passes. And after that time passes, you write some code, you deploy it, and then you get that data back out, right? The thing that you were trying to hypothesize about or the value that you were trying to deliver. And when we talk about accelerating, what we really mean is that time, which is called lead time in lean manufacturing, we want to minimize that time. So the process that we're going to talk through today is about setting up a CD pipeline that helps us minimize the time from I have an idea to that value has been delivered, or that hypothesis that we're testing, we're getting data about that hypothesis. Does that kind of make sense? So the definition of lead time in this is lead time clock starts when the request is made and ends at delivery. So to do that, to minimize that time, we're going to build a system that allows us to do continuous delivery. And continuous delivery, sometimes people get confused between the terms continuous delivery and continuous deployment. Continuous delivery doesn't necessarily mean that every single change I makes it into production. It means that at any point in time, we can deploy to production. And so another way to think about that is that the decision about when to deploy is not one that is formed by our schedule or developers or technical restrictions. It's really a business decision. The business says, hey, we had this idea, you implemented it, and now we think it's a better idea to have that feature implemented or that data being collected than to not have it. And so the business gets to make that call. So the features we would want to have in a continuous delivery pipeline like this, first and foremost, deployments really need to be non-events. It needs to not have a lot of special ceremony around it. I've worked in environments where it's like a deployment is something you spend 3 months preparing for, down to deployment is something that I do 15 times a day. So there's a few attributes to that. For them to be non-events, they need to be regular, and what I mean by regular is that they just happen frequently, not necessarily on a consistent basis. They need to be predictable, which means when we run this script or we're deploying the software, we know what it's going to do, right? It needs to be something that we're not afraid of, right? And what we were just talking about a moment ago, we want it to be driven by business. Another feature we want is that we want deployments to be all-encompassing, and that means infrastructure and code. How many people here have stayed up late at night trying to do a deployment because some server wasn't provisioned correctly, and now I'm working working late because I got to provision that server first, or the database for production wasn't created properly, or these kinds of problems are very, very common. And so what we want is we want a deployment to the unit of deployment not to mean just deploying the software that I've written, but we want it to be deploy everything. Sometimes you'll see that described online as immutable infrastructure. That's sort of a buzzword that encapsulates what we're talking about here. We want deployments to be repeatable. Really, what that means is it's not just saying I want to deploy the latest version always. To be able to say I want to go back to a previous version, or I want to deploy in a different environment, I want to deploy a different version. Basically, repeatable means that what it means to deploy something is going to change over time, right? You might add caching, you might add a Redis cluster. Well, what happens when you want to deploy a version that doesn't have that Redis cluster? You still want to be able to do that. And what often happens is you have deployment systems that are versioned separately from the software that's going to use what they're deploying. And so what that means is that you can never really go back in time, or you can never do anything except for the main line. It causes a lot of problems in automation. And then another thing that we want is we really want it to be able to be easy to do scaling, monitoring, and logging. Basically, what often happens is a lot of people sort of roll their own solutions for these things. We really want it to be easy out of the box to do the right things for those. And what that is going to ultimately look like is using Docker containers, especially for the scaling component, because when you use Docker containers, you can just add more servers and have the same containers deployed out amongst them and scale horizontally. So what we want our deployment system to look like is something like this, where, forget about the left-hand side of this, these two are different Git repos. And what we have in service 1 is we have our application. This is some Python service. And then the application is going to use certain pieces of infrastructure. And so what we have here is a directory that represents, I have this application. What does it mean to have that application deployed? Well, it means having the code running somewhere. And it also means, in this case, maybe I have an S3 bucket that I'm using. And what we want is we want to see those two things versioned together. If we have something here, this is essentially infrastructure as code, versioned along with the code that's going to consume it, then it's very easy to go back and say, well, you know, three commits back in Git and be able to see maybe that S3 bucket wasn't there. Maybe we had a database before we replaced it with S3. You're able to see those things change together. So I want to give a short demo of what that feedback cycle is going to look like. And importantly, I'm not actually going to show any of the tools of the CD pipeline. I'm just going to show what the experience of making a change to infrastructure and code at the same time is going to look like. Is that mirrored now? No. There we go. So this thing's the thing that we kicked off at the beginning here is, actually you can't see it at the bottom, but I can. Here we go. It's started deploying a couple of the tools that as part of the CD pipeline, and this is going. We'll take a look at it at the very end here. So what I want to look at is we have this sample app. It's called My Awesome App. It doesn't have anything in it. It's just this stupid web page, and I can also see the top of this, but you can't. And what we want to do is we want to do something cool and new. We want to have static assets, right? Right now, this is just all HTML. We want to start building some images, putting them in S3, and then referring to the images in S3 rather than hosting them as part of our app. It's kind of a common practice to put that stuff behind a CDN these days. We're going to do something kind of like that. So on the right here, I have the source code to this app that we're looking at here. And right now, it's just an index HTML that's literally what we see here, and a Docker file. And that Docker file says that we want to start with an Nginx stable. Does everybody know what Nginx is? Just a, yeah, okay, cool. So it's going to start with Nginx stable. It's going to copy all the files in the current directory into where Nginx is going to host from. And that means that basically what we have on the left-hand side is a static website. But what we want to do is we want to add an S3 bucket. We want to start putting some resources in there. Sorry. We want to start putting some resources in there and add them to our site. So we're going to look at this infrastructure project. And I have the code kind of here already commented out. This is Terraform. We're going to look at Terraform a little bit more in a minute. But let's just take a quick look at this. What we can see is that we're creating, actually I'm going to make this font bigger. We're creating a resource that's an S3 bucket. S3 is basically just a key value object store in AWS that you can access over HTTP. And we're calling it static assets. We give it a bucket name, and we have a policy that allows it to be accessed anonymously over the web. And then we are adding to that S3 bucket, we're adding a JPEG that I have on my local file system called pool.jpg, and we're adding it to that static assets bucket. So I just uncommented this piece of code so that it's actually going to create these resources. And I have this little image tag that's going to reference that resource that we're uploading, this cool.jpg. And so I'm going to commit that. And the kind of key thing there is that those two things happen together. I created some infrastructure that my application needed, and I also am consuming that resource in my code. This would apply the same kind of logic to databases, caches, search indexes, those kinds of things, where if you can describe those resources and version them along with the changes that consume them, then you're able to move forward and backwards in time. So I'm going to push that to a Git repository. It's going to take about, let's say, maybe about a minute, and we're going to see it, this mysterious cool.jpg show up on the left-hand side here. Any questions so far? I should say, just feel free, if anything's confusing or you want to ask questions, feel free to interrupt. You don't have to wait till the end. Let's see if this is updated yet. I'm not actually sure that it's refreshing. It is. Nope, no, not yet. Let me actually go and make sure that it is deploying. 2 hours ago. That's not recent. This is actually interesting. There we go. Give me 1 second here. Make sure that it is what I think is happening. Yeah, it hasn't kicked off the build. Let me restart the agent. Yeah, let me restart this agent. I may need to kick off another build in order to have it go. Okay, so it's going now. So, little sneak peek. This is Drone, which is a CI/CD build tool, and it's actually going, and we can actually look at the steps here that it's doing. This is happening in a project called About RiseUp on my local disk that I just pushed up. It built this, and then it kicked off this downstream build shared infrastructure, and that maps that picture we looked at a moment ago, where we had the shared infrastructure project referencing the specific service, and basically that went and reconciled the infrastructure that we want to exist with the infrastructure that already exists. And we'll take a look at how that works here in a second. So if I refresh here, now our awesome app has a wolf moon. So what exactly happened there? What happened is that we made that change. We built this About RiseUp project, and it cloned the repository, and then it went and built the Docker container, which has that index HTML that's referencing that static resource. and then it goes and kicks off this downstream build. That downstream build is this shared infrastructure build, which is just running Terraform. And Terraform is a tool that will compare the world that you want to exist with the world that already does exist. And it'll say what things that you want exist and what things don't exist. So as an example here, if we look at the actual build log, we're going to see it say that the software that you're wanting to deploy is different from the software that's already on the machines. Additionally, you're saying this green and a plus sign here is saying I want to add a static assets S3 bucket, and then all this encoded crap is the image that I'm uploading. And so it's saying that there's two things that it needs to add, the S3 bucket and the object on that S3 bucket, and one thing to change, and that's the software. And so those two things changed at the same time. And that's the really powerful thing here. So we're going to go a little bit meta as part of this conversation. What if we could take these features that we just talked about as part of a CD pipeline, the thing that I just demonstrated, and actually apply many of them to the CD pipeline itself? What that means is that creating a new CD pipeline is really a non-event. Creating a new CD pipeline is all-encompassing. Everything that you need to use it is contained in the project. Being able to deploy a CD pipeline is repeatable. Many of these same features we just talked about, all the things that we want for building our software, what if we were able to make a CD pipeline that does the same thing? So that's something that internally we've been working on, and we're going to look as part of this conversation sort of under the hood and how it works. We'll learn a little bit about Terraform and the tools that we're actually using. But the idea here is that oftentimes when we go into clients, they already have an existing suite of tools. People are using Jenkins, they're using Stash, or some other Git server, and it's really hard to get started doing continuous delivery when there's an existing ecosystem of stuff, and there's many dependencies before you can have a workflow like what I just showed, right? So if we were to build such a pipeline, such a thing that could be recreated easily, and by the way, that thing I kicked off at the beginning of the talk is creating a new CD pipeline, just like we saw. We're going to need some things. We're going to need some kind of build tool, some sort of continuous integration tool. We're using Drone.io. We'll take a look at, I think it's actually just normally called Drone, but we'll look at a couple of reasons why we chose these tools in a moment. We're using Rancher for Docker orchestration, and what Rancher basically does is it says, I know about the servers that you have, I know about the services that you want to run, and I'm going to reconcile those and schedule those services to run on those servers. What that means is when a new server comes online, it automatically gets software deployed to it. When you add a new service, it automatically figures out how to deploy it to all the servers in your cluster. We also set up a Git server, and the rationale here is not to replace a company's existing Git solutions, but what it really is has anybody here used Heroku before? So you know that if you're working with Heroku, the last thing you do before your code shows up in production or in your environment is git push, right? We're kind of doing something like that. We're not really trying to replace Git solutions, but the idea is when you're ready to push your code, that business decision, you push to this remote that we spin up, and the entire process will kick off from there. Another thing that a lot of people struggle with is that you can use Docker Hub's private registry, but you only get like one or two of your own private registries. And then if you're like wanting to do cool stuff with Docker, now you got to go get somebody who has budget to go and like put their credit card number in to get your Docker images, to have somewhere to put your Docker images. And also, often that the process of setting up your own is actually not easy. with all of the SSL rules and stuff like that, getting the right certs. It's actually kind of a complicated process. So we're automating that too. And then the last thing that we want is we want it to be all HTTPS out of the box. And if you think about this, most of these things, somebody in almost every single company has spent a significant amount of time building, if not building more than one time. And so the idea is, what if we could take what generally takes weeks, sometimes months, into minutes? And that's what we're trying to do. So I want to walk through some of those tools that we just talked about to understand a little bit of why drone, why Rancher, what are these tools for? So we're going to start with drone. So just out of curiosity, what build tools have people mostly used? Almost everyone in here, I'm guessing, has used Jenkins at some point. What are some of the tools that you've used?
What was the old school before Jenkins? It was
Hudson.
Cruise control. Oh, yeah.
Hudson.
Cruise control was like the original one.
Yeah.
Jeremy actually worked on the Ruby. And you know Jeremy Lightsmith? Yeah, so Jeremy worked on the old cruise control tool way back in the day.
Yeah, I used to work with the guy who started that project too. Yeah, CCRV or something. Yeah. Any other tools that folks have used a lot? People use the JetBrains ones.
Synergy.
I haven't used that.
No, nobody has.
Okay. I haven't even heard of that actually. So there's a few things that. Okay, last question. Who here has set up a CI server? Okay. One of the biggest. I'm looking at you guys as I say this. One of the biggest pains with it is about setting your CI server up correctly so that it has all the dependencies and the environment set up to actually run your builds. So as an example, if you have a database, maybe that CI server needs a database set up on it, or maybe if you're using Selenium, you need to have Firefox on it to make sure that you can automate Firefox. So some of these problems seeming familiar in setting up CI servers?
The right Java version.
Yeah, exactly.
But then if it's shared, then like one person upgrades it and kills everybody else's ability to build.
Exactly. So the idea with drone is someone said, hey, we have these things called Docker containers, and what that means is that the way in which we run software is always the same regardless of environment. What if we could take those same principles and apply them to builds such that you don't need something special set up to set up your build agents, and that any computer could run them. In fact, what if your server could run the builds and so could your local machine if they were all just Docker images? So in this particular case, let's take a quick look at the build script for our About Rise Up, the project that we just changed here. And hopefully, if you look at this, you look at it and think, this looks a lot like Docker Compose. How's it going? This looks like a lot like Docker Compose, and that's intentional. This basically, drone took Docker Compose as the basic format, and what you do is in code, you specify what your build pipeline looks like. So in this case, there's two steps, one called publish image and one called downstream. Publish image goes and builds a Docker container and pushes it up to a remote repository. So in this case, we are building the About Rise Up image and pushing it to this repo that's on our private Docker repository. The second step is the downstream build step, which goes and kicks off the shared infrastructure project. The only thing that's really important here is that these steps are just Docker images. So what that means is that running the build, there's nothing special to set up on your build server besides it needs Docker installed. If it's got Docker installed, then it can run all the steps. You don't have to worry about JVM versions. You don't have to worry about, does it have the right dependencies installed? And if you have something special, it's very easy to build your own Docker images. In fact, like building a Docker image is a really easy way to get some good open source, publicity, because there's such a market for them. So that's the number one reason why we chose drone, because the ability to basically run your build anywhere. The number two reason, and this is a little bit more common nowadays, and that's that the build itself is versioned with the code. This file that I'm looking at, drone YAML, is in my Git repository. And what that means is, when, just like we were talking about infrastructure, your infrastructure needs change at the same time as your code does, so do your build steps. You add a database, and now you need to start using that database. Or you add a new kind of test, right? You don't want your build to run a set of stuff that no longer applies to an older or newer version, right? The ability to version those things together means that it's always replayable. And then the final advantage here is that it's very easy to run your builds locally in the same way as you run remotely. So how many people here have run into a situation where it's like, I ran all the tests on my computer, everything's working there, and then I pushed my code, and then the build's red, and everybody's angry at me because I broke some tests. It gives you a much better sense of whether or not it works because you're running the same thing as what the server's going to do. Any questions about drone?
One of the things I would mention that I've heard a whole lot, just for everyone in general, is because drone is like a container automation kind of pipeline thing, everybody thinks that it's for publishing containers only, and only for building like Docker stuff. I would say, is that true or not? Like,
I don't think that's true. So meaning you can do a lot more than just that. So the idea is that one of the things that can be a little bit difficult in learning about drone is that oftentimes the means by which you accomplish something and the thing that you're accomplishing are actually the same thing. And what I mean by that is drone is a Dockerized build server, which means that all the steps happen in a Docker container. And oftentimes, like we see here, the artifact of our build is a Docker container. And so there's a lot of overlap there, but they're actually completely distinct. We could build a tar GZ and upload that to some FTP site. That drone could just as easily do that. It's just most of the time when people are using Docker, they want a tool that makes it easy to build those Docker containers. They find drone, but really it's so flexible while not being cumbersome. It can do a lot of what we used to do better than the tools that came before it. Any other questions about drone? So next, let's take a quick look at Rancher. So Rancher is how we are automating the deployments. So let's take a quick look at my production environment. And in my production environment, I have one server. This server is running a bunch of containers that Rancher starts on them, but is running my about container, and that's basically this website that we are seeing here. So the first thing that Rancher gives you is a lot of ability to go and do ad hoc investigation, right? So I can see everything I can see all the servers that I have and everything that's running on those servers, and I can even go in and look at the logs of the applications that are running on those servers. But it's much more than just the ability to monitor those things. So here is, sorry, this looks very, very different when it's what's the word I'm looking for? Huh? Yeah, it looks very different when it's narrow. But this is.
Can you make it like take half, like no, not.
Oh gosh.
I wasn't meaning bigger, but more like not full screen and shrink it to like the internal part of the screen.
Let's see if that looks any better.
Yeah.
It'll also be full screen in the video. Just
Okay.
FYI.
Okay, cool. Good to know. So what I want to show here is that this is running my service, my About Rise Up service. That's this thing here. And what we can see is that its representation of that service is actually just a Docker Compose file. Sorry, this doesn't really look that good. Maybe it'll look better as dark. I don't know.
No,
It doesn't really
always the light thing.
Okay. I don't know what to say. It's hard to read this here, but this is basically a Docker Compose file that represents that service that we're running. What that means is that there's a lot of overlap in how you represent your services on your development machine. Oftentimes people use Docker Compose to run a bunch of services on their machine, and how you run them in Rancher. And then what happens is you're able to set up scheduling rules that say, which kind of servers do I want to run this service on? How many of them do I want to run? Do I want to run one on every server, or do I want to run 10 of these services no matter which servers they run on? It gives you a lot of flexibility in how to do that. But even more importantly is that it has an API, and that API allows you to create these automatically. I can come in here and I can manually add another service, right? I could start up this Ubuntu image here and it'll start it up on that server. I could start up Nginx, I could start up an FTP server, I could start up a lot of different things. But it has this great UI for being able to see these things, but it also has a great API. And on top of that, somebody built a Terraform provider for Rancher, which allows us to automate deploying the software in the exact same way as we're creating AWS resources and other things. So hopefully it kind of demonstrates some of the value add of Rancher here. Finally, we set up a Git server. We chose Gogs because it's one of the most lightweight Git servers out there. The use cases we have for it are really not to have thousands and thousands of Git repositories. The idea is if these continuous delivery pipelines are easy to create, why shouldn't each team just own their own, right? And so when I'm working on one team, I can spin up a CD pipeline and start being effective on day one. And I don't have to go talk to another team to make sure it's okay if I change something about the CD pipeline. If it's easy to create, they'll become much more common. So the idea is we don't have a lot of dependencies on this beyond it's a way to kickstart the build process, right? We need something to monitor, and rather with integrating with an existing system, we can just spin up a separate Git server. Any questions so far? Oh, go ahead.
If you already have a system, you can keep using that, right?
Yeah. So the idea, the model we're going after here is that something like Heroku, where you add another remote to your Git repository, you use the source control you already use, but when you're ready to deploy, when that business event happens, you push to this remote and it goes from there.
Well, and I don't know if this is what you're asking as well, but you could also replace like Gogs with.
Yeah, that's right. If you said, you know what, I don't want, like, there's a few things. We're kind of interested in pursuing other options. If folks do want to use this thing for their real source control, we might choose a different tool. Or when you run this CD pipeline, it gives you this stuff, but you really have the freedom to tweak it from there and say, you know what, I want to integrate it with the thing we already have. I want to integrate it with GitHub. I want to integrate it with Stash. And it lets you be productive on day one and sort of allow the integration points to be backlog items.
Is Gogs like an Alpine version of like Git, essentially?
It's more like an open source GitHub Lite. So it's somebody read. Gogs stands for Go Git Service. So somebody wrote. It still uses the standard Git binary,
Right.
but it's just like the whole UI and web front end on top of it.
Okay.
And
It's
one
it's
of
kind of like
it's
GitHub
lightweight.
Enterprise or like
GitLab.
GitLab is like probably the closest thing to Gogs.
Oh, gotcha. Okay.
So yeah, like this UI that we're seeing here, I mean, it looks a little bit like GitHub, and that's because they modeled it after that. And it's basically just a lightweight way of having somewhere where we can push code to and then trigger webhooks from there.
So you're literally having your own Git repository.
Yep, that's right.
The thing I like about it is because like Git oftentimes because we're used to having like a central repo like SVN or whatever that's the source of truth.
Right.
Then we keep assuming that is the source of truth. But having like this kind of model is like, well, there's not like you choose what is the source of truth. This is only like a tool to enable the build step to start, not.
So this is probably like a tangent, but like what we should do about like making sure that your code is basically not going to die, or like it's not going to. You're gonna have some sort of backups of it, all that kind of stuff.
Right. So the reality is that when somebody deploys the CD pipeline, I think what you're getting at is that this is something that's hosted in your own environment,
Right.
and that's something that you inherit, and you are responsible for maintaining. When people think of that Git server, it can seem scary because it's like, well, what if that disk crashes? The first thing is that we aren't really want to be in the business of replacing companies' central Git servers, because that's a thing to own. This is more of like an entry point. And if, for example, this server died, and I'm using GitHub or I'm using GitLab or some other internal thing, the impact of this thing dying is really not that big.
Are you still pushing up to like their remote then?
Yeah. So in my normal development workflow would be I'm making my changes, I'm pushing them up to my company's standard Git repository. When I'm ready to deploy, when I say now's the time to deploy, I push it to a separate remote that triggers the build.
And so, but then what's the point of having your own local remote, or your own local essentially repository of that? Was that by you? I didn't get it.
So are you thinking that there's three because there's only two?
Two, yeah.
Okay. Yeah. So the rationale there is that integrating with a Git server is a lot of work, and it requires it's a dependency of getting started doing continuous delivery, right?
Yeah.
So you go into a company like Nordstrom, you go into a company.
Well, think the amount of work that it took just to integrate hooks from Stash, just to be able to say, hey, look, start a build.
Right.
Insane.
Right. It's a lot of
It took
work.
like 2 months, I think.
What if it's a proxy, what if you're using an old version, there's all sorts
Right.
of variables. Now we control the variables if we own
Right.
Gogs.
Right. So
to be clear, it can do both.
right.
So the idea is that basically for all the hooks and all that kind of stuff, like drone taking hooks to be able to build off of, it's going to use that locally, and then you're going to push up to basically their main repo to make sure that they still have the code essentially.
That's right. That's right. So
All right, that makes sense.
yeah, and the idea is that lets you be effective and productive on day one,
Right.
and then you can make your decisions about what level of integration you want to take from there. You can say, I don't want to use Gogs. I'm going to integrate drone to talk to my private thing. Great, you can do that. But to start with, you have the entire pipeline working right off the bat.
That makes sense because you can eventually then kind of parlay that to be like to move whatever company you're currently working at to then adopt that stuff. But you're right, getting something like adding like a hook into GitHub or like their central Git repository.
It's like leaps and bounds work. In the political work.
Right, that's the thing.
Yeah.
No, that makes sense. Okay.
So I'm just continuing on the demo here. When the thing was spinning earlier, I hit enter a bunch of times, which consequently passed by a whole bunch of prompts. I didn't realize that hitting enter in the middle of it would answer questions that would come 15 minutes later. So I'm going to get to those questions and answer them here, and then we'll keep going. But basically, what I've been kind of doing while we've been chatting here is some of the last steps of setting up the pipeline. So what's happened is that it's created the pipeline. I went and created a user, and I need to get essentially my API key and plug it in here for it to do the final steps. So we're going to plug those in, and then we're going to look a little bit at the under the covers. How does this, or under the hood, how does this stuff work? How does Terraform work? And we'll see how the thing that we're using to deploy infrastructure and code together is really like put to the battle test in deploying a very sophisticated CD pipeline. So I'm going to go and log into the drone server that was just created. Oops. And get my API key. So you can see I've got this drone.zebra, I've got this gogs.zebra, and I've got a rancher.zebra. And I have a registry.zebra. All the components of the CD pipeline are basically now created and integrated together. So I could start pushing my services, start writing some code, and deploying them right away. So I need to grab my token here.
Well, isn't that a contribution we're going to try to get to, is to be able to have the token?
Yeah, to automate this process, to get the API key. Yep, that's right.
The PR you're supposed to do, right?
So-
no, I was doing a PR for Azure, which I'm starting to really hate.
So all I want to show here is that in our new drone.zebra.my domain name, we have the same 3 projects that we have in the one that we've been working for in this demo so far, all ready to go, ready to start deploying services. The entire pipeline is working together. If I push code to that Gogs repository, it's going to kick off the builds and start going. So the idea is that it even sort of ships with a small, simple service for you to start working with. So let's get back to some of the technology under the hood here. Gosh, why doesn't this work? There we go. So to set this up, it's really a 3-step process. The first thing we do is we create an AWS user and a VPC. And from that step onward, that user that we create is the user that all the rest of the steps are going to work with. So the idea is you are an administrator, let's say, on your own AWS account. We don't want to run every single thing that we're going to do using your admin account. What we want to do is we want to create an account with trimmed down permissions that's sort of traceable to this particular environment. So we create that AWS user in a VPC, and then what we do is we spin up Rancher, and we actually have it as an option to spin it up in high availability mode, where it starts 3 servers so that if one of them goes down, it's still up and working. And it will create those servers in that VPC. And then finally, after Rancher is up, what it does is it goes and deploys Drone, a private Docker registry, and that Gogs service all on Rancher. So if we actually look here really quick, those services, these things we've been looking at, are actually on Rancher. We can see Drone is here, the Gogs server is here, the private registry is here. It's actually Rancher that's hosting the CD services that we're using, and so it actually allows us to upgrade those services in very much the same way as what we do when we're building our apps. So how do we do this 3-step process? Well, to create an AWS user in VPC, we're going to use Terraform. To deploy Rancher to this VPC, we're going to use Terraform. And to deploy Drone, Docker registry, and Gogs services with Rancher, we're going to use Terraform as well. So it's going to be kind of important to learn Terraform. Sorry, I just really wanted to get those transitions in. So I want to give you like a little bit of a 10,000-foot view of what Terraform does, because it's really the backbone of both how we want people to build services and infrastructure together, and also how we ourselves are putting that to the test by building that CD pipeline, right? And so what we do is Terraform knows about the world that exists. It knows that out there's an RDS database, and there's some EC2 servers and some DNS servers in a Rancher stack. And in a bunch of configuration files, you specify the state of the world that you want to exist. I want these DNS servers. I want those EC2 servers. I actually don't want that RDS database anymore. And I want these cache servers in S3 bucket. But these don't exist yet. These do. And this Rancher stack exists already, but it's changed, right? We upgraded to a later version of a particular piece of software, those kinds of things, right? So what Terraform's going to do is going to say, you used to want this RDS database, you still want these things, you want this thing changed, and you want these created. And so when we were looking at it before, when I added the S3 bucket and added that image, we looked at what was called the Terraform plan, and it said, I need to create 2 resources, and I need to change one. I need to create this S3 bucket and the file that I'm going to upload to that S3 bucket, and I also need to change the Rancher stack to point to the newer version of the code. And so what you do is you specify the desired state of the world it's going to track the existing state of the world, and it's going to create a plan of what needs to change so that those are reconciled, so that the picture at the end is this one, right? Get rid of this, change this, and add these. So I'm going to go through a couple quick Terraform terms. Resources are basically the things that you are going to create. Resource is kind of a really generic word, like component, right? You use it kind of all the time in code or in tech stuff. What does it mean in this context? It's actually really generic. They're things you create. So maybe you create a server. Maybe you create a DNS record. Maybe you create a Rancher stack, right? That Docker Compose that we saw earlier. Maybe you create a database. But the means by which those are done, resources are just specified as configuration. They're basically just keys and values. The database name is this. The users that are allowed to access it are these, right? It's just key value information about that resource you're wanting to create. Providers are the things that actually go and make it so, right? So provider is going to say, you want to create this EC2 resource, this server, and I'm going to go and actually run the AWS API commands to go and create it. Think of it as like providers are the implementation, and resources are the things, right? And then in Terraform has this idea of variables, sometimes called vars, and what those are in your configuration files, you can reference variables such that when you call Terraform, you provide the variables and it'll inject those values in. So what that lets you do is basically run the same file in multiple contexts. So you can run one file for production and one file for a staging environment, or the same file for the staging environment, just changing the values. A dependency is kind of a really cool thing that Terraform supports. You noticed earlier when we created that image, we created the bucket, and we also created the file in the bucket. What Terraform does is when you reference one resource from another, it creates a dependency. And when it creates that dependency, it now knows which steps have to happen first. How many times have you been in a situation where like, yeah, I need to go and upload this file somewhere, and actually the place it needs to upload to doesn't exist yet, right? That's what dependencies do, is it creates a graph that allows it to determine the steps, the order of the steps, so that you don't have to do them one by one in an imperative sense. It's much more declarative. And finally, a plan is basically this here, the comparison of the world that exists to the desired world and the things that need to change. So let's take a quick look at what a Terraform resource looks like. So in Terraform, this is something that kind of looks like JSON. If you ask me, they probably just should have used JSON, but they didn't. So I'm not going to explain the details of the syntax. Just pretend that equals are colons and that it's just JSON. In this, you specify that you want to create a resource, and then the second parameter there is the resource type. And so we're saying we want to create an AWS instance that's creating an EC2 server. And then the third parameter is what you want to call it in your code, right? We want to call this Rancher on-demand agent. And then inside of here, you say all of the parameters for that resource. And so the things that we see in here are going to be different on every resource. You can create a Rancher stack in Terraform, and you can also create an EC2 server. You can create a DigitalOcean server. You can create an Azure server. You can do all of them. But the parameters that you're going to specify in those contexts are going to be different, right? So some of them are static, right? We want to create one server. Some of them are doing interpolation of a var, right? So when this Terraform command was run, you're expected to provide a Rancher agent instance type. So in this case, that's like T2 micro or some server class that's in AWS. Or here we have an environment name. Maybe that's called production, or an owner, or in our case of that new CD pipeline we just created, it's zebra.aws.brycecovertoperations.com. So those are interpolations of the variables, but you can actually notice how they all start with var dot. Here, we're not actually interpolating another variable. We're actually referring to another resource. So it's not in this code sample, but there's another resource specified called with a type of AWS key pair and a name of rancher agent, and that has an attribute called key name on it. And what this does, I was just talking about the dependency tree or dependency graph that it creates. This is saying before you can create this AWS, well, it's implicitly saying before you could create this AWS instance, you need to have an SSH key created for it, and that's specified elsewhere. So what's really great about it is it doesn't matter if I put that SSH key below or above or in another file, Terraform's going to decide which steps need to happen first. I know that this can kind of be a lot for when you're seeing it for your first time. Any questions about just the basic structure of these Terraform resources?
So $sign means...
It's kind of like Bash,
Variable.
where it's a little bit more than just variable. It's interpolation. So
It's like, why is $sign lookup? That's obviously like a function, or?
yes. So good question. So, sorry, I want to make sure I don't break this. What this is that in this case, this variable environment name is just a string. So you say, I want to create when you run Terraform, you say, I want to create my production environment, and then it's going to tag this with the name production agent, right? In this case, what lookup is, it's a function that Terraform's implemented, it's not implemented by us, that operates on a dictionary type of variable. So Rancher OS AMIs is not a string, it's a dictionary, it's a key value lookup. And the AMI, it's just kind of a thing about AWS. AMI is basically the virtual machine image, and the ID for a virtual machine image is different in every region. So what we're saying is we want to look up the proper image name, image ID, based off of the region. So there's a variable specified somewhere for all of the images, key value with region, image ID, and then you're passing in the region that you want, and it'll look up the appropriate one. So does that make sense?
The environment variables come from where?
They're command line. For the purpose of this discussion, they're command line arguments to Terraform.
So you literally run some sort of command line interface and then pass that in.
Okay, it's a good question. So for region, yes. You pass in, I want to run this in the US West 2 region.
Right.
This variable is actually defined in this file. The value is defined. So basically, that it's not looking up, one variable that you specify in the command line to another variable you specify in the command line. It's really looking up the region in a constant list of images in this case.
Grab me the right server for this region,
Right.
or this right OS.
Right. So this is perhaps a little bit more of a complicated case, but what we're trying to avoid here, if we didn't do it this way, you want to spin up a server, you need a virtual image ID to use, and before you can run your Terraform, you need to go and find what that ID is, and you're like, I have to go search through AWS, find this thing, and that's a really big pain. If you try it, it's not fun. The idea here is we went and looked them all up for you. You just give us the region, and we'll plug in the correct
So your
ID
AWS
for you.
key pair, is that in code, or is that being passed on as a...
It is in code. I'll show it here. So specifically, this one is in our agent. So yeah, this is a good question. So here's where we define those. So we have. Let me make this a bit bigger. Oh gosh, hang on. Let me make this not full screen so you guys can see it. Here is where we specify the variable Rancher OS AMIs, and basically, if we didn't do this, someone would have to go and look up all of these values, right? But the regions are well known. So I'm saying, when I run Terraform, I'm saying I want to run in the US West 2 region, and what it's going to do, if I find that same place, is it's going to look up in that collection of, that map of AMIs, the region that you specify, and inject that value there. Does that make sense?
Yeah.
And kind of a similar thing here. Element is another function in Terraform that allows you to look up in a collection by index, right? So they're saying, give me the first subnet. That's what that's saying there.
Oh, so it's like literally like giving like the first element of the array essentially.
Yep, that's right. Cool. Any other questions before I move on to a couple other Terraform things here? Cool. So I want to start with something that's maybe a little bit easier to understand in Terraform. Actually, let me make sure I didn't have anything else I wanted to show here first.
Yeah, so
I can pause while folks go to the bathroom.
Bryce, how does this work with coming into a new client and then wanting to do production versus test versus dev? Like, can you spin these up independently, or how does that work?
Yeah, that's a good question. So the first thing is that when you are creating a service or an application, what you want to do is you want to think about what does it mean for this thing to be deployed, period, regardless of environment. Now, there might be something different about production, right? You might need 30 servers in production and 1 in development, or you might need to have a different class of server for production and development. In the case, it can get way more extreme there. Maybe you don't have caches in development, right? So the first thing you need to think about is what does it mean for this thing to be deployed, regardless of which environment it is, and frankly, the more you can put into that bucket of stuff, the better, right? The more you can make your non-production environment look like production, the better off you're going to be, right? So if you've done that and you find that, wow, well, everything's that way, right? Then all you do is you build a Terraform configuration that has the variables that are different in these different environments extracted out, and you run the same Terraform configuration on the different environments, right? In fact, on one of the other projects we have internally, like that's what we're doing. We just set it up earlier today to make it so that in drone it goes every build it's going to deploy to a testing environment, and then you can manually say I want to go and trigger a deployment to this production environment, and it runs through the exact same thing just with different variables. Now that's not always something you can do, but the thing that naturally comes from there is to build into Terraform the configuration that is different based off of the environment. So you can have, if you imagine let me go back to, I'm just going to give a very simplistic case here. If this is a situation in which we want a fixed number of servers. So if you were in a situation where you're like, well, in production, we have way higher demand, right? I would not solve that problem with what I'm about to describe here. I would use auto-scaling or something like that as a better way to configure that. But what you could do is you could say, I want to have 1 server if it's development and 10 servers if it's production. You can do in Terraform, you can do it's something like this. Actually, I think it's var environment equals production 1. Actually 10 versus 1. You can do ternary ternaries built into it.
But is this something that you could do for like spinning up multiple environments?
Yep. So to be super clear, on this other project, what we've done is you don't need to create anything. You say you kick off a drone deployment and give it an environment name, and it will deploy every single thing that's needed to run. Even the environment name is not specific, meaning you could say deploy an environment called Bryce or Banana, and it will create everything that's needed for that. So it's one of the things that I've learned about this. So I've messed around with Terraform before building everything we're looking at here, and if there is a way to put it through the paces, it's building this thing, right? This is a very complicated CD pipeline integrating multiple different, services that had each other in mind, but not, didn't have an integration story. Being able to put all those things together in a repeatable way, I have found that Terraform can solve those problems pretty well. Does that kind of make sense?
Yeah.
It's kind of hard to put it through the paces in a more intense way than what we have here. So I wanted to walk through just a few things in Terraform. So what we're looking at here is some of the code of what deploys that CD pipeline that we looked at the beginning. And I just want to show a couple of the varieties of things that Terraform can do and show the consistency that you get across those different things. So we looked at an example of creating an S3 bucket earlier. That was an AWS resource. We're going to look at a couple more AWS resources, and then we're going to look at Rancher resources and templatized directories and just see how the way you do things is very similar between them. And that makes it really easy to do multi-cloud or do more complicated deployments using Terraform. So yeah, we can see this. So this is more AWS stuff. So what we can see here is this is I described that three-step thing. We're going to create a user. We're going to deploy Rancher with that user. Then we're going to deploy all these services on Rancher. This is the thing that's creating that user. So it's creating an access key for a user. And actually, you can see here that this is an example of specifying something out of order. So we're wanting to generate basically an AWS API key for a user, and we're passing the user as a parameter here. That user is defined below, and that creates that dependency, right? When Terraform runs, it's going to go, oh, I need to create this user first, and then the API key based on that user. So here is the policy of in AWS, they have their own scheme for this stuff. It's very complicated. I can never remember off the top of my head. But AWS has a policy that allows you to say what users are allowed to do, and we're uploading that policy, attaching it to attaching that policy to the user down here. But one of the cool things is like this is a reason of why Terraform created, or HashiCorp created their own data structure syntax. You can use here docs. Here docs are just a way to do big inline text, multi-line text native to the language. So we can put all of the permissions that this user is allowed to have in a JSON syntax, like right in the middle of the file.
Oh yeah, because you can't do that in YAML.
You can't do that in you can do it in YAML. You can't do that in JSON.
JSON. Okay.
Yeah.
So if they chosen YAML, then it was okay.
Yeah.
But not
Yep.
JSON.
And then finally here at the bottom, we are attaching the policy to the user. So you can actually, if you just imagine that dependency graph in your head, you need the user before you can attach it to the policy, and you need the user before you create the dependency, or you create the API key for the user, and then you need the policy before you can attach the policy to the user. So there's like a somewhat complex graph, and if you're just like writing imperative code to create these things, chances are you're going to get it wrong at least your first time. And the resolution of those dependencies I found is really, really impressive from Terraform. So this is what it's like to create AWS stuff. Let's take a look at creating something in Rancher. So over here we were looking at, this is the project for that sample app we were looking at, right, where we had that wolf picture. And if we look at, actually let me do this. If we look at the infrastructure project, we have the Terraform that describes what does it mean to run that service. And what it means to run that service is to create a Rancher stack, to create a load balancer, and attach the servers to that load balancer. What we're going to focus on here is just the Rancher stack. So what we do is we pass an environment ID. So we can see that this actually follows the same syntax style as what we saw in this syntax is the same as what we saw for AWS, but this is talking to a different provider. Generally, the provider is the first word of the resource type. So that this is hitting a completely separate code base to talk to Rancher. And we say we want to create this about rise up stack. We give it an environment ID, a Docker compose, and a Rancher compose. Any values we want to inject into it, and it will go and create that stack in Rancher in that environment. And it also allows us to, like I was saying, this environment thing allows us to inject values from the Terraform context into the stack. So we talked through a deployment scenario earlier where like, oh, I deployed, but the database hasn't been created yet. Or maybe we're really smart and we create databases, but we don't name them because they're dynamic and we expect to inject them. Well, now maybe before you deploy to your production environment, you need to know your database name to put it in the config file. What you can do with Terraform is you can create your database and then inject your database to your Docker Compose and override like an environment variable that tells it what the database name is. So there's a really seamless process of creating dependent resources in the cloud and then handing them off to your application to consume. So what that means is that you remove a lot of things from your config file and you let them be dynamically created. And you don't have to have a specific naming convention behind them because you can let the names be automatically generated. Does that kind of make sense?
Is it globally distributed?
Say again?
Sorry, your typo's driving me crazy.
Oh, yes, it is globally. Yes.
Okay, just checking.
Does that concept make sense though? The idea of creating the database and then injecting it here, and you could do it with S3 buckets. You could do it with many things, right? I could say if this thing was referencing an S3 bucket, I could say equals AWS S3 bucket, and I can reference a resource that I actually am creating here and inject those values in. It's really, really powerful. Okay, so we looked at creating AWS resources. We looked at creating Rancher resources. Now let's look at kind of a more extreme example of creating, it's actually over here, creating templatized directories. So one of the things that we do is that when you spin up that CD pipeline, what we really want is we want people to be able to start using it right away. And what that means is we actually want to deploy their first service for them and give them the source code to that service. But what it means to deploy that is going to be different in every CD pipeline. So we want to basically have a Git repository that's a template and overwrite certain things in that Git repository. And so what we can see here, template repos. So what we do is the about rise up project, your Git repository, comes from a template. And so here, what we do, this is a different provider. There's actually a template provider that you give it a source directory, a destination directory, and all the things you want to swap in the files, and it will basically do a copy and replace anything that refers to registry server will be replaced with the value of the registry server, and so on. So what that allows you to do is basically templatize entire directories, or in our case, Git repositories, and that's done. The kind of key takeaway here is that's done in the exact same way as we create AWS resources, exact same way as how we create Rancher stacks. And if we just look at the collection of Terraform providers, it is very, very large. And we've also internally worked on a couple of projects where we create some ourselves. And the way that this works is not that Terraform is one gigantic binary with the ability to talk to these 500 different cloud providers. Actually, they're maintained by different people, and they're sort of all included a la carte when you want to run them. So if you're using DigitalOcean, you can create DigitalOcean servers. If you are creating local files, you can use it for that. There's many different providers out there, and it gives you a common language and a common way of creating those resources apart from the implementation. So that's a little bit of the under the hood of how we're creating CD pipelines.
That
Yeah.
last thing you just talked about, the templates. So if a company has reference implementations as starting points, could those be deployed alongside the CI/CD pipeline?
Yeah, that's right. So one of the things that we have so far with the CD pipeline is that like it's Terraform. You're running the Terraform. We sort of have that. Even the starting point for what your CD pipeline looks like, you have the code to it, so you could go and say, you know what, this sample service that's just an Nginx, with an index HTML is not the starting point. We mostly use Node here. You could go create that sample repository and give it to people very easily. Yeah. So I know that we kind of covered a lot of things and went through, level 1 and then a meta level on that, and then under the hood of the meta level. So any questions or comments about how all this works?
Is everybody ready to start doing it tomorrow?
Yay.
It was amazeballs.
Amazeballs.
I think the hard time I had with all of this is the Terraform syntax is actually kind of like takes a little bit to get used to.
Mm-hmm.
Well, it's just not a thing, right? That's part of the problem.
Well, it's not. If it was YAML, and I wish they would have come with YAML, it would have been rad. But Terraform does have its own
It's almost like a syntax.
Well,
You gotta
is.
learn a new language almost.
If they were backticks, then the interpolation would be just like JavaScript.
Right. Yeah, I'm not a huge fan of the actual data structure syntax. I will say that my first thing going into it is like, what does that actually mean? What is resource and AWS, like, what does that actually, like, I want to know, is that a map? Is that a list? Is that a dictionary? Is it a tree? I don't know what that thing is. I have learned to come to grips with that and realize that, like,
the value.
the value of actually understanding that is actually very, very low. It was a difficult barrier to entry to understand that. It was called HCL. That's what this syntax is. Understanding HCL was.
I kills me every time.
Oh, what's that?
HCL is a
Indian outsourcing firm. It's basically Infosys.
Okay, I see. It was a barrier to entry for me because I wanted to understand it. Like, I don't like just typing stuff and not understanding what that actually means. But, I mean, if you can just live with the fact that that first word is not in quotes, and then the next one is the type of thing you want to create, and the next thing is the identifier, you'll be all right. What I'm saying is it's very easy to use, and wondering what it does under the hood, I thought would be important to understand how to use it, and it turns out it really isn't.
How do you debug this, or like do you just do this and then see what happens, or?
Yeah, so a lot of
Is
people.
that part of the problem where like basically you kick the shit off and then like
See what happens?
yeah, it takes like 20
You
minutes
kick it over
and
the
then you
fence.
find out it turns out it just breaks.
Yeah, so it's a really good question. So there's a few things to note there. The first is that the fastest it can possibly go is the speed at which the resources can be created. If you go in the AWS UI and you create an EC2 instance, it takes a couple minutes.
Yeah.
So there's no making it faster than that. However, who here has used CloudFormation before? So hopefully, I should have mentioned this at the beginning. A lot of what Terraform does is like CloudFormation, but with end providers, right? With the ability to do the same kind of stuff with different.
Just less shitty.
Yeah.
In a way.
Yeah.
I don't want to like.
But
shoot
CloudFormation,
myself.
yeah. But one of the big things about CloudFormation is kind of hard to get a good picture of what's going to happen when I run this. Terraform is really different in that before you do anything, it creates a plan. And so that's what, when we looked at this shared infrastructure build, that's what we are seeing here, is this is what it intends to do. It intends to change, it's hard to read here, but this is saying it intends to change the about, rise up, stack, and rancher, and to add an S3 bucket, and to add the object or a file to that S3 bucket, essentially. And if you are working in small increments, which I think is good, your ability to understand the changes that you are planning on making is very high. And what that means is that you don't. There's been some work in the CloudFormation world to be able to get sort of a diff for what's going to happen, but just the ability to see what does it plan on doing, and that takes seconds, not minutes, not hours either. The ability to find out what it plans on doing helps resolve a lot of problems, and oftentimes it'll tell you about an error in that plan step. It can get a little bit weird where, like, if you're wanting to, say, delete a VPC, but someone went and added a server to that VPC just like manually, you're kind of screwed at that point, because in the world that Terraform's watching, that server isn't included. But if you kind of stick to it, I have found just observationally that the amount of oh shit, I forgot that thing is much lower than using something like CloudFormation.
When it runs, are the environments that it creates in AWS protected from people doing, as you said, like going in and just adding a service that Terraform's not aware of?
No. So to be entirely clear, like that's like the power is yours. You can make Terraform do whatever you want. In our CD pipeline stuff, we're not doing anything to limit users from that. However, if you are in a larger organization, chances are not many people are going to have admin access to the root AWS account. And so the permission structures are likely to not allow people who didn't create something in the first place. In this case, the Terraform user is being given jurisdiction over the resources it's going to create. And we want, like, a thing to do is to make sure other people don't, like, you as the owner of your AWS account need to make sure that other people don't mess with things that aren't theirs.
Yeah. I wonder if it would be possible to build a sort of testing or verification framework at the end of it that actually makes sure that everything you stood up is what you expected and does what you expected to do.
Yeah, so we're pretty close to that. So you saw I had that manual step where I went and created my user in Gogs, and then I had to kick it back off again. But remember that the place at which we ended up, if we look at drone.zebra.aws.operations.com, if we look at this, all of the repositories, our sample service, and the infrastructure that is required to run that service, all of that stuff is in my CD pipeline. Like, we're very close to the point where, and we press the play button and it goes and creates all that stuff. So meaning that your verification of it's done is you run it, and then half an hour later you can hit this thing. There's probably not going to be a wolf on it. It'll probably have more documentation. But the idea is that it doesn't just set up a CD pipeline, it exercises it the first time for you. Say, and if you want to deploy a service, here's an example of how to do it. It's in production already. Go and hit it. Or it's deployed already.
And we've talked about the aspect of it being even in different languages, where it's like
Yeah.
Golang, Java,
Yeah.
whatever.
So yeah, the intention. So you might ask, what is this about Rise Up service? So I've intentionally not really talked about Rise Up a whole lot as part of this discussion, because RiseUp is the name we're kind of giving our product that creates this CD pipeline. And this isn't about our product. It's about the under the hood. How does Terraform work? What's the philosophy? Not the product itself, right? But the idea is that the service that we intend to deploy, my intention is for that to be the documentation for what you just created when you created that CD pipeline, as well as all the starting points. So, hey, you want to create a Go service, you want to create a JavaScript service, you want to create a Python service, like literally on that page, instead of having a dumb wolf, we have links that are tar GZs of, if you want to start a Node service, download this tar GZ, get remote add, and off you go. So the idea is it makes it really, it's a little bit more like Heroku that you own, but the ability to start building services really, really quickly and giving you those starting points.